So here we have a condition given to us that a, b, and c adds up to pi radians. We need to show that cosine squared a minus cosine squared b minus cosine squared c, that's equals to 2 times the product of cosine a, sine b, and sine c minus 1. Okay, let us begin our proof from the left hand side. On the left hand side, we have cosine squared a minus cosine squared b minus cosine squared c. Now what we'll do, we're going to take a help of an identity. The identity being, if we have cosine squared alpha minus sine squared beta, then this is also expressible as a product of two cosine function given by cosine of alpha plus beta times cosine of alpha minus beta, which means that we need a sine squared function here. Now we know for a fact that sine squared theta plus cosine squared theta equals to 1. This is a standard identity, so we can convert any cosine squared function to its sine equivalent as 1 minus sine squared theta. So what we'll do, we're going to transform the second term in a expression. So here we have cosine squared a minus, now in place of cosine squared b, we're going to use 1 minus sine squared b minus cosine squared c. So that's further simplified to get cosine squared a minus 1 plus sine squared b minus cosine squared c. Now here we need cosine squared alpha minus sine squared beta. So what we'll do, we're going to keep the first two term as it is, cosine squared a minus 1, but we're going to take negative as the common factor and combine the third and the fourth term. So this gives us negative times cosine squared c minus sine squared b. Now we can apply this particular formula. Now let's do that. So this is going to give us cosine squared a minus 1, and we have negative. So c can be assumed to be alpha and b will be beta. Then in that case, we should get cosine of c plus b multiplied to cosine of c minus b. Okay, fine. Now what we have here is cosine squared a minus 1 minus cosine, the product of two cosine function. So let's work with this cosine of a. So here what we can do, we can use the fact that since a plus b plus c is equals to pi radians, so b plus c can be also considered to be equivalent to pi minus a. Now let's take the cosine function on both sides. So we have cosine of b plus c, so that's going to be equals to cosine of pi minus a. Now what is cosine of pi minus a? We know that's going to be negative cosine a, negative sign, because we are in the second quadrant as dictated by pi minus a, and in the second quadrant cosine function is negative in nature. So now we have cosine of b plus c, that's going to be the same as negative cosine of a, provided we meet the condition that a plus b plus c equals to pi radian. Now what we can do, in place of this cosine squared a, we can replace it with cosine of b plus c. So squaring it is going to give us, or let's do one thing. Let's keep it as cosine squared a minus 1. But what we do, instead of cosine of c plus b, we replace it with negative cosine of a. So this becomes positive cosine of a multiplied to cosine of c minus b. The reason why we considered cosine of a in place of cosine of c plus b, so that we can combine the first and the third term by taking cosine of a as the common factor. So from cosine squared a, if we take cosine of a as the common factor, that leaves us with cosine of a, and from the second term we have cosine of c minus b. Okay, and then we are left with negative 1. Now we have cosine of a, so we need to combine two cosine functions. So let's do one thing. Let's again transform cosine of a back to cosine of b plus c. So we have negative cosine of b plus c added to cosine of c minus b, and then we have negative 1, and we're going to rewrite this. We're going to rewrite it to get cosine of angle a multiplied to cosine of angle c minus b minus cosine of b plus c, but let's rewrite it as c plus b. That's going to help us simplify further. Now what we have is the difference of two cosine function. Now whenever we have two cosine function and we have the difference, for instance cosine of alpha minus cosine of beta, then this simply transforms to give us 2 times the product of sine beta plus alpha over 2 multiplied to sine beta minus alpha over 2. Okay, so here C minus B, that corresponds to alpha, and C plus B corresponds to beta. When we use the formula, we're going to get cosine of A multiplied to 2 times sine of, so beta plus alpha means C plus B added to C minus B, that gives us 2 times C divided by 2, multiplied to sine of beta minus alpha. The beta minus alpha is going to give us 2b, and we have division by 2 minus 1. So final simplification gives us 2 times cosine of angle A times sine of angle B times sine of angle C minus 1. So let's verify that this is the result that we want. 2 cosine A, sine B, sine C minus 1. And that's exactly what we have obtained. So this is the right hand side. And thus we can finally say that the left hand side equals to the right hand side. Hence proved.